science in the beginning of the 20th century. The world is simple, and we can discover what is God saw. And that's my understanding what should happen. So there's a philosophy of science for complex world. So now we don't believe that world is so simple, because if you're talking about physics, how many parameters you connected in one law, 3, maybe 4, and what type of functions can be linear, polynomial, degree 3, not more complicated. So just very formal. But when you solve it, say, any diagnostic problem, you involve much more parameters, much more complicated process. So the law, we believe, we saw actually, we not believe, we saw that laws of nature is much more complex than just physics, and how behavior is behaved. And the first metaphor, again, by Einstein. Saturn is law, but Militians, he is not. And this is my interpretation. Saturn is law, one cannot understand his thought. But Militians is not, one can act well without understanding that. So it is two different things, to act well and to understand well. And it is interesting when you open the book of Picturani, Casey Picturani and Friedman. So, and they gave a table of best algorithm in data mining. And they have a column which says interpretability and generalization ability. And you can see that algorithm which can interpretability, this book interpretability, predict better. And vice versa. It is two different problems. Because you cannot do both. You should choose what you want. Or you would like to explain, or you would like to act well. But what in this case you explain, you cannot act well using this explanation. And we should understand that in new complex world, the goal of it, we cannot say to have a goal to know what's solved. And also it is still post problem. We should avoid solving the post problem. We should not go in the way which it is not, we don't need it actually. And the second is that devil imitates God. It is definition of devil. And this is an interpretation action based on your understanding of God's thought can bring you to the answer. And it is the same story about the impostor. So you solve something which you cannot solve, and you think that you're right, but then you have according to that. But don't do that. And this is from the statistics. If God does exist, then many things. Are forbidden. And that means that if subtle and non-malicious God exist, then many ways of generalization must be forbidden. And subject of new philosophy of science, and this is actually the most important part in doing it. Not just math, because it is another story. I initially wanted to say that actually math repeat whatever was done 30 years ago in different languages. New, it is but the most important part is this philosophy. What should be done next? Where is improvement of our performance? Where is it? What will be progress? And the progress will be the subject of new philosophy of science to define imperative. What should be forbidden in general? This philosophy actually defines the success of generalization in real high dimension. But let me give you an example of what means imperative. And it's very simple. I just like joke, made it in 95, and then I realized that it's very serious. Solving problem of interest, don't solve more general problems as intermediate step. Try to get answer that you really need, but not more general one. And it is not easy to follow that. To understand what is the basic real life problem, it's of course not enough. Sometimes it is not transduction, and it can be selection. But maybe there is something which is simpler than selection. And what is that? Because the simpler problem, in the sense is that they far from impossible. The better solution, the more accurate solution. And in more dimensionality. And the example, don't estimate density if you need to estimate mass. It is clear density is universal problem. I start with Kolmogorov axiomatization. If you have, say, probability measure, you can solve everything just by deductive inference. And it is you have very specific implications. Don't use classical statistical paradigms. Use some new paradigms. Don't estimate function if you need to estimate value of function. Try to perform transduction, not induction. And then don't estimate predictive value if your goal to act well. Good strategy of function not necessarily needs review on good theory. And what else? And that is the most interesting part, because you're actually changing philosophy. And the mass is important because you understand your philosophy, you're trying to prove, but the real bottleneck is in understanding of general philosophy of fitness. So actually, everybody from your point of view is a very beginner position, because you should, of course, it's good to continue to classical work, as was done before, but also it is very good to understand what is the basic problem and what is the advantage of this problem, comparing to whatever we saw in general, say, listening with the framework. So, thank you.
Thank you very much for your talk. It was very enjoyable. Philosophy was also very enjoyable, but I will refrain from asking a difficult question. Maybe more like historical. At some point, when you explain the basics mathematics, you say that the key point is that what this gross function can be either linear or logarithmic. It's kind of surprising.
Yeah.
So we had a course this morning, and I asked you if you could explain to me intuitively why is it so behind the combinatorics. So my question is, could you give us some maybe intuitive interpretation, and also how did you come to maybe guess this property or to, yeah, that's my question.
If you have tree and cut one branch, you cut into one. That's just I can say. And then we said, but you're not just cutting one branch. You're cutting in the branch some future development, in any branch. So it's something like that, but it's not so.
More questions? So as we can try to convince Vladimir to stay for half an hour at the bar, maybe be less reluctant to ask questions and approach him directly.
Oh, yes.
It's difficult for him to say no.